is mythically a sort of story behind that. So this is Rear Admiral Grace Hopper from the United States Navy, who had her PhD from Yale and actually is known for many things, but among them is for working on the Harvard Mark I computer that looks a little something like this in black and white. It's now housed across the river in the Science and Engineering Complex at Harvard, which you can visit if you hop across the river someday. But in the Harvard Mark II, another successor to this large mainframe computer, Dr. Hopper was responsible for keeping the logbook. And pictured here is, if we zoom in here, the first actual case of a bug being found. Some kind of moth was physically found inside of the Harvard Mark II, disrupting its operations. And that's not literally what we mean nowadays when it comes to bugs in software. And this really just popularized the term. It wasn't the origin of the term itself, but that's among the stories that gets tossed around typically when talking about bugs and, of course, debugging. So among the goals for today is to actually make your life easier when it comes to solving problems this week and onward, because odds are you were a bit in the dark if you had some mistake in your code last week. You could have, of course, asked the duck. You could have asked a teaching fellow or teaching assistant. You could have struggled through it. But let's actually give you more tools in your toolkit to solve problems. So here, for instance, was one of the simpler problems we did last week. And we'll keep it simple so we can focus on the debugging techniques and not the complexity of the code. And recall that this example was all about just printing like a column of bricks using hash symbols, otherwise known as ASCII art. Well, the first debugging technique we gave you and encouraged you to use last week was, of course, this virtual rubber duck, or even a physical rubber duck. In fact, on the way out today after class, we have not only these ducks, but like hundreds of others. If you'd like to walk home to your dorms with a rubber duck, and we'll bring them to those of you at Yale, you may at day's end. But the virtual version of this is, of course, powered by artificial intelligence. And not only will the duck listen to your questions, it will try as best as it can in English or some other human language to respond. But the general idea of rubber duck debugging or rubber ducking is to talk to an inanimate object like this, or nowadays an AI. And again, per week 0, in that process of sounding out your confusion and telling the duck, like a teaching assistant, what your problems are, odds are that proverbial light bulb will go off and you'll realize some illogic, some mistake you've made, at which point you can actually solve it yourself. But when the problems get harder and when the material is especially new, it's not going to necessarily come to you off the top of your head. So let's give you some more techniques. It turns out that one of the most common and useful ways to debug code is literally with a function we've used since week 1, printf, because printf lets you print anything you want, including the contents of what's inside of the computer's memory, so to speak, inside of your variables and functions and the like. So let's go ahead and do this. Let me switch over to VS Code here. And let me go ahead and create a new file that deliberately is called buggy.c. So code buggy.c. And this will be relatively simple, include standard.io.h, int, main, void. And then inside this, let me aspire to print out this column of bricks here of 1, 2, 3 bricks, top to bottom. All right, back in my code, I'm going to do for int I equals 0. I want 3 of these, so I'm going to naively do I less than or equal to 3, I plus plus. And then inside of my for loop, I'm going to do printf, quote unquote, hash sign, \n, close quote, semicolon. So if you're already pretty comfortable with C and for loops at this stage, you can probably see the bug already. But again, the focus here is on techniques, not the actual code. It looks like I've done something stupid, though, because when I do compile this code, and I'm going to do make buggy instead of bothering with Clang, because we now can sort of stipulate that we know there's more going on there, but we don't need to care about it every time. /buggy is not going to print 3. It's going to print 4 of those hashes instead. All right, so how do I go about wrapping my mind around what's wrong? Well, I remember from class I'm supposed to start counting from 0. If I want to go up to 3, it's less than or equal to 3. So we could probably reason through this without much effort. But let's suppose that this is representative of more sophisticated problems. Well, printf here can be your friend. If you want to see what's going on inside of this loop, I would propose that you temporarily maybe add a second printf that says something like this. I is, and then I'm going to use a placeholder, %i, \n, close quote, comma I. So if I just want to wrap my mind around what's going on every iteration of this loop, let me just literally print out the contents of that variable. So let me remake this, make buggy, /buggy, enter. OK, now let me enlarge my screen. What has happened? I is 0, I get a hash. I is 1, I get a hash. I is 2, I get a hash. Oh, I is 3, I get another hash. So the solution here is one of a few things. I could either regress and start counting from 1, but in general, I would propose do what programmers do, start counting from 0. So if I leave I at 0, what is the correct fix here? So just change it to less than 3 instead, which again is sort of the convention, even though it's by no means the only way to do this. If I go ahead and do that, let me clear my terminal window and make it larger temporarily. Make buggy again, /buggy. OK, now I got it. I is 0, I is 1, I is 2, and I only get hash, hash, hash. So printf is your friend. Just remember, certainly in the context of a class like homework and in the context of the real world, once you're done using printf to debug your code, go in and delete it. So it's not printing out a confusing message to the auto grader, the correctness tests, or the like there. All right, so that's how you might use something like printf. But what if I did something a little more sophisticated here? Let me do this. Let me change up this program and get rid of the for loop. And let me, for the sake of discussion, just make it a little more complicated. Let me go ahead and create an integer called h for height. Let me ask the human using getInt for the height of the column of bricks that they want. I immediately have to go in and add the CS50 library, because if I want to use getInt, that comes with CS50, not with standard io.h. Once I've done this, let me go ahead and call a function that doesn't yet exist, but will print column of height h. And this is sort of where we concluded roughly in week 1, whereby I factored out some of the functionality for printing a row of bricks. Today I'm flipping it around to say print a column, because now I'm going to do this. Void print column. And then the input that this will take is going to be the actual height, but I could call that anything I want so long as it's an int. And here I'm going to recreate the correct code. For int I equals 0, I less than not 3, but height, if I want to genericize it, I plus plus. And then inside of the loop, I'm going to go ahead and quite simply print a single hash and a new line so that it gets hash, 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 1 per line. But there's technically a bug here. Let me hide the terminal window and scroll back up. What one mistake have I still made? I'm missing the prototype, right? Because if I compile this as is, the Clang, the compiler, as we now know, won't know what print column is, because when it sees it for the first time on line 7, it has never seen it before. So the solution, of course, is to copy paste, and this is almost the only time copy paste is acceptable and encouraged, that first line of the function itself. All right, let me open my terminal window. Let me run make buggy. It seems to work. /buggy, enter. And it's gone ahead and done, let's see, 3. This is the correct version. So just a bit of a sanity check that it's working as intended. Now let's break it. Let me hide my terminal window. Let me make the same mistake as before. And let me say that printf for now is your friend. But by week 3, week 4, week 5 in the real world, you're not going to want to just start printing everything out, because you're going to be printing so many darn things. You're going to have to then go remember to delete the stuff. It's going to mess up the output. There are better tools. And even though this week it will take you more minutes to play with and get comfy with what I'm about to show you, this will pay off in hours over the course of the term and in the real world. Spend a few extra minutes this week playing with a proper debugger, which is going to introduce you to more sophisticated techniques for debugging your code. We are going to run now a program called debug50, which sounds CS50 specific, but that's only because it automates the process of starting VS Code's built-in debugger for you. So this is not a CS50 thing. This is representative of a debugging tool you would have in the real world available to you. And VS Code is among the most popular. So let me go back to my own code here. Let me open my terminal window. And let me confirm now by recompiling buggy, enter, and running /buggy. Now we're back to the problem where if I type height of 3, I'm getting 4 hashes. So how can I wrap my mind around why that is the case without using printf? Well, what I'm going to do now is this. I'm going to run debug50, and then I'm going to run the name of the program /buggy. So debug50 is a program that expects its own command line argument. What program do you want me to help you debug? I'm going to go ahead and hit enter. And I made my first mistake. Looks like you haven't set any breakpoints. Set at least one breakpoint by clicking to the left of a line number and then rerun debug50. So what is a breakpoint? Well, let me hide my terminal for just a moment. A breakpoint is sort of a stop sign that you can add to any one of your lines of code and tell the computer, break execution at that point. That is, run my code, but pause temporarily here so I can poke around. So what I'm going to do is, because the first line of juicy code is at line 8, notice if I hover in the so-called gutter of VS Code, there's this little stop sign or red dot that appears. I'm going to hover over line 8. And as directed, I'm going to click, and it gets even redder. That is a breakpoint. It says, run my code, but stop at this point so I can poke around. Let me reopen my terminal window, clear it, and do this again. Debug 50./buggy. Enter. All right, so a whole bunch of stuff seems to be happening automatically. It's a little confusing at first glance. I'm going to zoom out just so we can see more of it here. I'm going to go back to the terminal window, because notice, there we go. In my terminal window, I have a blank window now, because why? Line 8 is about to prompt me for input. So what has happened here? Well, let me go over here to the code. This is still my buggy.c file. Notice that there's a play icon here. There's some arrows. There's a stop icon and some other stuff. Notice that line 8, as hoped, is highlighted because execution has been paused on line 8 before it executes. Let's now actually see what's going on. At the top, though, there's some curiosities. All of my variables in this program that are currently in scope, that is accessible between these curly braces, are summarized here. Where did 32,766 come from? Any instinct for why h apparently has this weird value, even though I haven't even typed in anything, let alone such a big number? Yeah, how about over here? Yeah, I think that's a reasonable way to think about it. Maybe it's like a previous program used the same memory inside of the computer for something else. Maybe it was an integer, maybe it was a string or something else. So what you're seeing is actually what we're going to start calling a garbage value. It's like remnants of what the memory was previously used for. It has no significance to us. It's not a big deal because as soon as I let the debugger proceed one more line, the value of h is going to be changed to whatever the human actually types in. But what you're seeing is what's really going on inside the computer. You're certainly using and reusing the memory inside of your computer all day long because you don't want to run out, so you need to reuse it. So the debugger is letting us see that. So now, notice the arrows at the top of the screen. I can either hit play to say, like, just keep running the whole program, or I can do something like this, step over. So this second arrow here, step over, will actually run line 8, but then pause on the next line for me. And we'll see what else we can do in a moment. So I'm going to click step over. And now notice, in my terminal, I have been prompted for a height. Let's go ahead and type 3, enter. Now I've typed in 3. What happened at top left? Now the local variable, so to speak, local in the sense that it's inside of these curly braces, is in fact what I would expect, which is 3. Notice now that line 9 is highlighted. It hasn't printed anything yet, so let's step over line 9 too and see what happens with this value of h. Let me click step over again. The highlighted line becomes 10, which is almost at the end of the program. But unfortunately, I see 1, 2, 3, 4. Damn, like it's still buggy in this case. And honestly, this wasn't really enlightening setting the breakpoint there. I really have just slowed down the process of seeing my mistake. But it's still, in fact, there. So let's actually just run the program to completion. I'm going to hit the play button, but I could just as soon hit the stop button because they're equivalent because the program is essentially over. All of that is going to close, but my breakpoint is still at line 8. I'm going to do this. I'm going to leave that there. I'm going to run debug 50 once more. Let's actually step over this line as before to get my input of a height of, say, 3. But now on line 9, which is highlighted, let's not step over this because obviously that's just going to print out the same wrong thing instantly. Let's step into this function. Why this one? Because I wrote print column. Ironically, I also wrote getInt, but I'm pretty sure getInt is not incorrect. I'm pretty sure print column is incorrect. So let's step into it. The icon for that is the third icon here, the second arrow. Step into, click, and now notice that execution has jumped into the print column function. Nothing is printed yet because I haven't even started the for loop, but now I can actually poke around here. And notice this. This is an even crazier value for I, but for the same reasons. It's just some garbage value left over from whatever this memory was being used for previously. But the moment I click step over now, the second icon, now notice at top left, I is 0. and we're about to print a single hash. Let me click step over once more and watch the terminal window at the bottom. I currently have no hashes, but now I have one hash. Now the highlight's back on line 14. Let's step over that and watch as I do. At top left, i's value is going to change from 0 to 1 because that value just changed. Now I'm highlighting line 16. Let's click step over and watch the terminal window. There's my second hash. Let's step over line 14. Watch I at top left. I equals 2. Let's go ahead and step over line 16. There's my third hash. Let's now step over line 14 again. Watch the I at top left. Here's where you can see that, oh, I equals 3. But wait a minute. Line 16 is highlighted. I'm about to execute the darn thing again. Oh, that's why I'm getting the fourth hash. And if I do this one more time, step over line 14, watch what happens to I now disappears altogether. Why? Because I've jumped out of the for loop, because I became 4. 4 is not less than 3, so we're done with that for loop. And now if I go ahead and hit play, it's just going to run to the end of the program, which is essentially already that, because the curly brace was already there. So kind of tedious to walk through a program in this way, but notice it has given me the ability to step through my code line by line by line at a normal person pace, not at like a Mac or PC's pace, which is sort of over in the blink of an eye. To get rid of a breakpoint, you just click on the little stop sign again. It goes away, and your code will run as usual, even in the debugger. Questions, then, on this technique of debugging? Questions? OK. Use debug 50. OK. Use the rubber duck. That, too, should be helpful over time. But let's actually now take these ideas out for a spin and actually see what's going on in the actual computer's memory with these new techniques. So recall from last time that when you write code